Hello, everyone. My name is Ravi Sahu, and I am the founder and CEO of Strayos. Before I begin this session, I want to thank the organizing team of Hillhead Digital, who has done such an amazing job putting together this event to share the key insights for the quarry and mining operations here. And today's session, I want to share how you can use AI to achieve perfect ton and reduce drill to mill cost. Bit more about Strayos. Strayos is an AI solutions platform which takes the data from the upstream and downstream operations to understand how you can improve your mine to mill operations here. We're operational in 550 sites among 8 different countries here. One of the things that question comes to mind is what really the true definition of perfect ton is. And the answer sometimes is, lies in a very obvious statements. It's the more of you want what you want and less of what you don't. But depending upon the type of operation you are running, the market you are in, on the company you are working for, the answer to that question will be very unique. However, the factors that drive your perfect outcome are almost universally the same for everyone or every other operations. In this case, maximum safety, minimum effort, or maximizing your overall profit. When we project all these three things together, the perfect ton of the production process becomes easy to evangelize among your upstream and downstream, as well as easy to envision as well. But how do you balance the what would have to be present and balanced with each other? Because the implication of all this is that better you understand both the upstream and downstream operations and manage your workflow, the closer you come to getting this perfect done. When what is essentially important also is how do you get the perfect done and solve a problem for different parameters. In this case, which is any drilling and blasting that happens upstream as well as the downstream, how your plant is set up. But how do you take into account all the different parameters that affect it? So traditionally, blasting and explosive engineers have tried empirical modeling. However, they are unable to incorporate all the various parameters that can't continuously changes for one operations to another operations. So while being easy to implement and better than nothing, there is still prone to errors and have accuracy concerns. So let's talk more on what exactly is AI is and how it can be applied in these scenarios. A lot of the times AI sometimes gets intimidating rep, but AI is nothing. It's just the understanding of how the algorithms can be applied and mimic human thinking so that you can apply at a scale for learning and problem solving your specific scenario. In this case, the algorithms can be programmed to operate within a unique data set that you have or identifying the patterns in those data set. And more importantly, you can do this over and over again to make these predictions for the desired outcome that you are looking for, or having to understand different scenarios or different variables. And these algorithms can be further trained to find anomalies and test in different scenarios so that you are covering all your bases for different variables. And not only you can do this at a massive data set or mountains of data, but you can do this testing at a speed of millions per second, which makes the scalability part for your operations becomes very easy. And that sums up it with this, very great code, like how Thomas Edison found 2000 ways not to make a light bulb, but only needed one way to make it work, which is in this case, you need one model to work so that you can apply that, for thousands of different scenarios which not working, but one that is working for that specific operations that you have. And so what is enabling the AI here? That the question that comes to, the next phase is why the time is right now unique to do this. And the way I look into this is there are factors enabling the AI, which is the autonomous data collection and 3D digital twins, which are happening on a daily basis in any job site, is going to enable the acceleration of the AI. And one of the AI is computer vision, which is autonomous remote sensing. So computer vision is constantly collecting the data. And one example is a technology is very prominent in mining, drilling, and blasting is any remote camera or remote sensing device, which are installed on equipments or in drones as well. But computer vision is simply training the algorithms to interpret data gathered from the images or pixels, which is identifying patterns on those pixels. And these images can be gathered not only by variety of sensors, but also numerous specific devices. And these sensors could include infrared, hyperspectral, magnetic data as well, even photographs, and many more different sensors. The devices can also collect data from satellites, cameras, drones, and so on. And in this specific case, your smart drills as well, which are equipped with generating huge amounts of valuable data that can be utilized to understand and interpret true geology. So the machines are playing more important role in your the perfect ton outcome here. In this case, the 3D digital twin can be easily generated, and then you can apply that and send it autonomously to the drills, which can help you not only find exact locations for the drilling, but at the same time can happen autonomously, very precise drilling. Easily within few seconds, you can find out if any deviations are happening. But more importantly, the data can be transmitted back to your 3D digital twin to understand what exactly the true geology that machine has given after drilling as well or while drilling. So now I have a true understanding or a true pulse of what's my the geologies and what's the probable outcome of these tonnages will be from this exact geology here. And you can apply that into various decision reporting as well for how do you break this specific section. But more importantly, why why it is useful for the AI. All these data sets that's getting generated from remote sensing, from the drill data, why is it important? The way I see it lies onto one thing, which is the AI secret sauce. The AI is nothing you are training, but it has a feedback loop which can become enormously powerful. And that's what it makes such a valuable addition to your toolbox. The algorithm is trained on a data set, but it identifies patterns and predictions, which are then compared to a new control set of data. And these models can be refined further to test on another new set of data. With each repetition, the models get increasingly more accurate and more advanced, and able to identify nuances to any specific particular situation that you may have or you may not have encountered before. And that makes it incredibly useful overall this process. So now taking the same concept and how to apply it in a drill to mill operations, which is continuous optimization you can do at each step. You apply at site surveying, where you can have your 3D digital twin, but the same data can be utilized now to understand the geology by automated detection using AI, then further expanding it to how you can use that to better interpret the drilling scenarios or plans, and then the blasting, moving on to the processing side, which is understanding the fragmentation. All this can be correlated back. So this is nothing but a concept of Lean Six Sigma, where you are continuously improving your processes, and this has been around since World War II, where you have the process of improvement, but the AI is truly enabling this in such a way because you have data in each different silos. If you can bring it together and put it into a feedback loop, the magic of AI can work behind the scenes, and you will find opportunities for continuous improvement. And if you want to get, the way I describe, if you want to get the upstream right, you have to get your, if you have to get your front end and back end right as well, which means upstream and downstream both. And the first real value is producing really the data and combining them together. And this is not just the case for today, but also the new operations that you would be developing over the period or the years. The capabilities of your operations continues to get better and improve real time, from here on. And you'll gain a competitive advantage for running your operations there. And this is where you can embed unique AI tools each step to understand and find those anomalies, where the leakage is there, or where you are losing certain valuable outcome, or the cost, or the profitability, and then really honing that down, that could affect your downstream operations as well. So identifying those scenarios, so bringing everything together as a comprehensive process. So if you apply that in a perfect scenario here, is you have a blast design data, drilling log from measure while drilling, machine data, geotechnical data, we have borehole survey data, and then the fragmentation data, and then also how my equipment performed based on the muck pile shape that was created or any ore movement information. And on top of that, the environmental related data like vibrations can also be brought together and then run in a various set of scenarios to understand where the improvement can possibly happen. And this is not uh, in a days, but within few seconds. This is just a use case how you can really apply and envision for your site as well in different, in a case of quarry operations, by applying not only understanding the upstream drilling and blasting improvement, which is up to 60%, you're also improving any type of dilution or the waste that was happening. So there's a recovery in ore loss itself, and that resulted into an overall annual savings up to more than $1 million for drill to mill case scenario here. So to summarize, the AI applied at a scale, it can really bridge the gap between your pre-blast and post-blast data silos. And what I mean by that is a lot of the times you have several contractors and you have different stakeholders working together in a same problem, but the data has been always structured in silos, and we often look into improving one silo but not improving the other silos, which could have been an impact from the adjacent silos here. So that's where combining everything together and really plugging the equations together can help and untap the enormous opportunity of this data universally. So, and then the insights gathered from one site with a similar particular geology could be used at other sites geospatially and combining, so that not only it helps in the planning of putting the operational performance or any type of decision making of what type of equipment will be required, or how do I design this, mine plan better, or mine development better, can help achieve those profitability goals for an operations here. But what worked well in one situation could also be applied to the other situation. And there is no need, again, for everyone to be struggling with the same problems anymore within your organization. And that's how you tap the real data-driven optimization for drill to mill here. Thank you, everyone, for giving your time and listening to me. I appreciate. If you have any questions, please reach out to me. Thank you.
Thank you, Ravi. That was a really interesting and thought-provoking presentation. I want to talk to you a little bit more, if I may, about the AI secret sauce, as you called it. What for you are the challenges of implementing AI for quarry operations?
Yes, So the challenge is that we see, or rather, it's more of an opportunity itself that is disguised as a challenge. Is we see the mindset shift. The stakeholders and the decision makers, they are willing to participate in implementation of AI, but it's the hesitations of how the accuracy will be. So these are usually the first set of challenges that comes in. But once we overcome the use cases and proof points through the data, and this is really implementing in a step-by-step will lead to these outcomes. We usually have seen the decision makers, go back to their boardroom and understand it start to make sense in their operations now. So those are first set of challenges, and usually the understanding of how bringing their internal organization into a common page as well, because they have different data silos, and how those changes will happen internally.
I mean, I guess one of the big challenges is convincing them that AI is as accurate, if not more, than what they're using already.
Yes, yeah, definitely. And this is again making them understand how AI will empower them more for some of the scenario that have been unknown before. Uh, and that's one of the key source that we have unlocked in convincing them that these are some of the untapped decisions that you were not even looking, and now with the AI, it can make it happen.
Do you think attitudes are changing? Do you think people are more trusting of it now than previously?
Yes. So uh, just about 2, 3 years ago, it was a very different scenarios where the understanding of or the hesitations was at almost at 60-70% level, that why we actually need this. And now we have seen it has gone past from the experimentation stage to actually the executives at the corporates or the organizational level. They are even putting together a plan of not only the digitalization, but they have a budget for the AI as a small budget still, but they want to see this as an initiative where they can take it to the level in the next 3 to 5 years.
Unfortunately, AI sometimes has a bit of an image problem, doesn't it? And I guess that's not helped by journalists like me, because by the time I hear about AI, often it's because it's gone horribly wrong somehow. Do you think it needs sort of a better reputation?
Yeah, yes, definitely. I think, and the industries like where are heavy industries, and especially quarries and mines. That's where I think the value that it gets generated and the positivity will happen, for the AI. AI has always been used on the other, scenarios or connotations from the machine or the robotics perspective. Well, we see the true use case and the true implementation in this industry, which will bring that, overcome this barrier of the reputation that we usually get.
So things are slowly changing. If we look forward, at what point do you think we won't even be talking about this anymore because everyone will be using it?
Yes, I think I want to get there to that scenario sooner, because AI is still a buzzword, and I don't want to be it as a buzzword anymore, because it is a mainstream, so nobody talks about it. And I think we are already getting there, and everybody there bringing together different forums at a industry level and talking the common guidelines and best practices, either forums like this. And as it's kind of maturing at a pace that we haven't seen before. So I believe in the next 3 to 5 years, organizations themselves putting this as a priority and making sure that what type of outcome that they want will start to rapidly change this process of uh, you going from a buzzword to actually becoming a mainstream and not a hype.
So in 3 to 5 years, I'm going to come back to you, Ravi, and we'll both be out of a job because nobody will want to talk to us about AI anymore.
I think the purpose is to empower everybody using the data and making those decisions, more powerful. I think we will just be empowered instead of be out of job.
Let's hope so. I think I prefer
Yeah.
the sound of that. Thank you so much, Ravi Sahu.